Okay, so in question 425, we are looking at an X linkage problem here. This is, I love X linkage, so this should be fun. So let's see, 4.25, in Drosophila, an X-linked recessive mutation called scalloped SD causes irregular wing margins. I guess they look like they're scalloped, I guess. So diagram the F1 and F2 results if a scalloped female is crossed with a normal male. And then we do the reciprocal cross for part B. So part A is scalloped female. So use the symbol for female, and the female must have two SD alleles crossed to a normal male. And remember, males are hemizygous for genes on the X chromosome in Drosophila and humans, because we both males in both types of animals are XY, have an X chromosome and a Y chromosome. So males are going to be SD plus, normal males SD plus, and I can indicate the Y chromosome with just a little mark like that. Okay, so we cross these two together. What's going to happen? Well, let's make the Punnett Square. Why not? It's easy. We could probably do it in our heads, but sometimes it's easy just to, diagram it with a Punnett Square. Easier to do that than just do it in your head. So females up top there, female gametes, I should say, and I changed my symbol for the Y chromosome down here. So the male gametes right here. So let's see, SD plus, SD, SD plus, SD. Here we have SD and a Y chromosome, and SD and a Y chromosome. So these are the female progeny. One half will be female, right? And then all the female progeny are going to be normal. So one half are going to be normal females, because we have 1/4 females here, 1/4 females here, 1/4 males here, 1/4 males here. All the females have a normal phenotype. For the males, 1/4 of them, okay, scalloped, and 1/4 over here scalloped. So one half of the progeny are going to be scalloped males. So all the males are scalloped, all the females are normal in the F1 generation from this cross up here. So, and that's the crisscross pattern of inheritance, right? Where moms are homozygous recessive for an X-linked trait. All of the sons will inherit that trait because the sons are hemizygous and they inherit the X from their moms, and the moms have two mutant X alleles. So all the sons will inherit the X-linked recessive trait if the mom has the trait. So let's look at the F1 before looking at the F2. Let's look what happens in the reciprocal cross, right? Reciprocal is just when we exchange the sexes and the phenotypes. So the mom here is normal, and the dad is scalloped. And we cross these. And let's fill out the Punnett Square again. Punnett Square with the mom genotype for each gamete up here, dad right here. And I changed the Y again. I don't know why I do that. No pun intended again. SD plus SD, SD plus SD, SD plus Y, SD plus Y. So here again, so all the females are heterozygous, so they're all scalloped. One half of the progeny will be they'll be normal. One half will be normal females, and one half will be normal males. So all the flies are normal in this cross here. Again, I can break them into females. Female genotypes are SD plus SD, and the males are SD plus with the Y chromosome. Okay, so we see differences right away in the F1 generation from the reciprocal crosses, and it's because these genes are X-linked, and males are hemizygous for genes on the X chromosome. So we have to do the F2 now, so let's take a look at that for both. We'll start with this one up here. Let me copy and paste this. So I didn't want to do that. Let's take a look. Okay, we want these because these are the F1 progeny from the first cross. Now I'll change the color here. Okay, so what we're going to do is we are going to cross these normal females here, all have the same genotype, to these scalloped males. Now this is the F1 cross from part A. So let's do the Punnett Square. Draw it nice and big here, which is unusual. Normally I draw it too small and you can't even see it. So SD, okay, gametes for the males on the left, gametes for the females up top here. SD plus, SD, 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 SD plus, and SD Y chromosome. My Y chromosomes look like 7s. I don't know why. Okay, so the phenotypes. We have normal, we have scalloped, we have normal, and we have scalloped. And these are females, and these are females, and these are males, and these are males. So we have a 1 to 1 to 1 to 1 ratio, normal females to scalloped females to normal males to normal males. Okay, so that's the F2 from part A. Now let's take a look at the F2 generation from part B. Copy and paste the Punnett Square that gave us the F1 genotypes. Okay, so in part B, the F1s are for females. They are all scalloped. No, they're all normal phenotypes with the heterozygous genotype. And the males are all normal hemizygous for the normal allele. So, and they have a Y chromosome, of course. So let's fill out the Punnett Square. SD plus, SD for the females, and SD plus Y chromosome for the males. SD plus, SD plus, SD plus, SD, SD plus, Y chromosome, SD, Y chromosome. And what we end up with, let's see, normie here, we have a normie, we have a normie, think that's from Monster High, where you have the monsters and the normies. Anyways, this one is normie and scalloped. Okay, and we have female. Nope, that's a male symbol. Female, female, male, and male. Okay, so here we have a ratio of 1/2 normal females to 1/4 normal males to 1/4 scalloped males. Okay, so that's the answer to 425 part B. And okay, that's it. So those are all the questions. So I now have all the questions finished for chapters 2, 3, and 4 that we need to cover for the makeup exam. So if you have any questions on these, come see me during office hours or email me if you can't make office hours, and we can make a separate appointment. Okay, see you in class.